making through deep learning and data engineering, right? So nowadays, you know that deep learning is very popular especially in the computing community, right? So for example, automatic driving. So we can use the, the deep learning, right? So likewise, there are many applications of deep learning and data engineering. And if you go to a conference nowadays, most of the research based on machine learning, and most of them are based on deep learning, right? So I think that this session may be a very interesting one. There are five presentations, but one is absent. So shall we start the presentations? So the first one is going to be presented by Miss Laveena Rajendran, and she will be presented online. Right, so she will present the presentation online. Can we arrange the online presentations now, please? So I would like to introduce Ms. Laveena Rajendran first. So Laveena Rajendran is a graduate with BSc Honours in Computing and Information Systems sorry, from Sabaragama University of Sri Lanka. Her current field placement is demonstrator at the Department of Computing and Information Systems, Faculty of Applied Sciences, Sabaragama University of Sri Lanka. Her field of research interest are data mining, machine learning, and deep learning. Okay. Okay, Ms. Laveena, can you start the presentation now?
Good morning to the panel. So I think the host has disabled my screen sharing. Can the host able to make me able to share my screen, please?
So first of all, can you share the presentation so that we can see it?
Actually, I couldn't share my screen. Now it's okay.
Okay, now we can see your presentation. Presentation topic is future forecasting and analysis of Sri Lankan tea exports in terms of driving forces using data mining concepts.
So can I start now?
Yes, please.
Okay, so good morning to the honorable panel, the lecturers, and my dear colleagues. I'm Laveena Rajendran from Sabaragama University of Sri Lanka. Today, I'm here to present about my research paper, which is entitled as Future Forecasting and Analysis of Sri Lankan Tea Export in Terms of Driving Forces Using Data Mining Concepts. So these are the main contents which will be discussed throughout this presentation today: introduction, methodology, results, discussion, conclusion, future work, and references. So now let's move on to the introduction. As we all know, Sri Lankan tea export is playing major role in Sri Lankan economy. So this is a picture from World News from 2015. Here you can see Kenya exports 25% of tea to the world market, while Sri Lanka exports 17%, which is least for our country when we consider about the historical records. And when we are talking about the factors that affect the tea export, there are a number of factors. So such factors can be classified as rainfall, temperature, and so on. So by analyzing the last research works, it's found there are some research problems. So those problems were carried out and analyzed in this research study. So such problems are how all these independent variables affect the tea production, and the negative positive correlation along the time that is to be improved, the accuracy of the past researchers, and also the examination of the priority in which the tea export will affect for a particular tea type, and the prediction of tea export for a particular tea type for a given set of feature that is to be improved in order to improve the Sri Lankan tea export. And these are some of the research papers which were considered as the reference to carry out this research process from the beginning to end. For the first paper, Sri Lanka's tea economy issues and strategies, this conveys Sri Lankan tea industry has lost its competitive advantage, and this paper gives a result as the reason for the low production is the lack of technology. And for the loss of tea plantation is due to low yield from aged plants, degraded soils, and under implementation of good agricultural practices. The second paper, it discusses the economic issues and government policies for the Sri Lankan tea industry. And here, they have results as the high cost of production have reduced the competitiveness in Sri Lankan global tea markets. And the third paper, which was written by Ms. KMV Sachitra and Dr. PJ Kumarasinghe, investigates the determinants of export competitiveness of tea industry in Sri Lanka. Here they have used quantitative research approach and Porter's diamond model. And for the primary data collection, they have used email survey, and then they have used partial least square structural equation model. Then in the fourth paper, it analyzes the present trend of Sri Lankan tea industry and identify the problem in international marketing of tea. Here, as a result, they have found increase of bulk tea in export is blended locally in the local markets, and increase the cost production is due to high wage of laborers, increased price of fuel, and increased electricity charges and high price of fertilizers. So these are some of the areas which were covered by this research study. So the main focus of this study is to analyze the influence factors for the Sri Lankan tea export by improving the past researches, and also it predict the tea export in Sri Lanka by analyzing the monthly export quantities of various tea types with the help of machine learning tools and techniques. And these are some of the evidences that there are some problems in the past researches. So there are no clear explanation is provided in how the author had used some of the methodologies, and risk factors such as weather and reforms in the tea industry were not considered. And also for the data collection, they have used expert opinion survey, pre-tested questionnaire, rather than using the machine learning technologies or any other tools, and also inaccurate data analysis performed. Now we'll move on to the methodology that is used in the research process. So as you all can see, this picture illustrates the overall methodology that is used from the research process. So as for the first step, the data collection was done. For that, recent past 10-year data set from 2011 to 2021 was considered. The official website of the Tea Board Statistical Department provided the basic information regarding the different tea types such as green tea, tea in bulk, tea in packets, tea in bags, and instant tea. And the data of crude oil price was obtained from the Federal Reserve Bank of St. Louis Economic Research Department, and the US dollar exchange rate was collected from Central Bank of Sri Lanka. From all the data collection, it was found that the total number of 630 features could be used for this research study. And then the data pre-processing was considered. Since the data were collected from manually, there were no null values and duplicates found. Therefore, the data cleaning and data reduction was not used here. And then the single data collected were integrated into a single database and then transformed in the way which the research could be used to conduct the process further. And then by considering the past researchers and analyzing them, it was found that the independent variables such as tea export earning, tea types, US dollar exchange rate, crude oil price, month and year is not that much used or considered for the dependent variable tea export in the past researchers. Therefore, these features were identified for this research process. And then the model was built with the help of VACA software to predict the tea export. Here 9 different classifiers were used, and then the model was evaluated by using the 20% of the final data set, and 80% of data was used to train the model that was built. And the effectiveness and efficiency of the model were evaluated by using the different criteria of the confusion matrix. Now we go on to the results that were found from the methodology. So for the model building, as I mentioned earlier, 20%, that is 126 instances were used to, from the entire data set. And by analyzing the different criteria of the confusion matrix, accuracy, precision, recall, the best accuracy model was selected to conduct the research study. So here you can see how the classification model was built with the help of VACA software. So this is a table that gives the accuracy and error rate that was found from the 9 different classifiers, which were built with the help of VACA software. So as you all can see, the multi-layer perceptron and random forest gave the same accuracy with 98.41%. But when we are considering the mean absolute error, the multi-layer perceptron gave the least error rate and the naive Bayes gave the least accuracy. But overall, all the performance of the classifiers were more than 90%. But by considering the error rate, it was declared that multi-layer perceptron is the best high accuracy model to use the to predict the T export. And then the attribute ranking, again, the VACA software was used to rank the attributes. From that, year, month, T type, and export earning were considered as the highly impactful variables, while US dollar exchange rate and credit price were considered as the least impactful features. And then if we talk about the findings, according to the T types, it's observed that tea in packets and were exported in the larger quantity, while instant tea was exported in the least quantity as per the month. Now we'll move on to the discussion. As per the main objective of this research is to improve the Sri Lankan tea export while examining the factors that affect the tea export. This study discovered some of the major factors that influence the Sri Lankan tea export and how they influence them. Also, it identified some of the major types of tea that are exported from Sri Lanka to the global tea market. From it identified that tea in packets are highly exported, while instant tea is least exported. And then to find the best performance model, 9 different classifiers were used. From that, multi-layer perceptron was considered as the best accuracy model. And also it is determined that year, month, tea type, and export earnings play an important role for the tea export prediction. So as for the conclusion, I would like to say that Sri Lankan Tea Board is the government national regulatory body. It has no system to predict the export forecast based on the tea types currently. So this paper investigates the feature that influence the tea export variation for developing the prediction model, which is more suitable. To foresee the tea export, multi-layer perceptron is more appropriate more than any other classification algorithm that were used in that were built from the beginning. Since this model gave only 1.5% of error rate, this shows that the predicted export volume is more accurate with 98% when compared to the original value. So these are some of the future work that can be done in order to enhance this research process. So this study can be further generated by a software application that could be built on the model pattern and the results discovered from the research. This platform should include the features like historical data entry, amount of forecasting actions, and beyond that investigation, the tea elevation auction prices, those can be considered along with the export value. And these are some of the references which were considered from the beginning to the end when conducting this research process successfully. And as for the acknowledgement, I would like to express my sincere gratitude towards all the academic and non-academic staff from the Department of Computing and Information Systems from Sabaragama University of Sri Lanka, as well as the General John Kotalavala Defense University for giving me such an opportunity to share my knowledge with you all. And thanks for listening. Now the presentation open for the discussion.
Okay, that was Miss Laveena. that is on future forecasting and analysis of Sri Lanka tea exports in terms of driving forces using data mining concepts. Right now, it's open to ask questions. So if you have any questions, please ask them. Any questions, please? So I have a question. So the first one, so you said that feed forward neural networks gave the best results. So how many layers have you used for this one?
Actually, it was used, not it was built manually with the help of Weka software only. I have built it. So since those algorithms are pre-built one, I didn't build manually.
Okay, then so you don't have any idea about the number of layers. So okay,
No.
so this is about forecasting. So why didn't you use a recurrent neural network instead of feed forward neural network? Because most of the time when you have forecasting, so better you use a recurrent for neural network. For example, you can use an LSTM. So why didn't you use such a neural network?
Actually, so when building this model, I was planning to get the best accuracy first, the best accuracy models, and going for an ensemble approach and creating a new model. Since because these SVM or LSTM, those things were used previously, so I have tried somehow novelty from the recent studies to this study. So that only I didn't use them because already they have used no. So that only I didn't go for that
So
option.
I don't know about Weka. Is it LSTMs or recurrent neural networks available in the Weka software?
Yeah,
Okay, then
it's
because
available.
that when you use the neural network, so because you don't, so we assume that the data are independent in the normal multi-layer perceptrons. But when you use the recurrent neural network, so we assume that the current data is depend on the previous one. So because that is more appropriate for forecasting. So for the next stage, I'm suggesting you to use a recurrent neural network, especially an LSTM. Okay.
Okay, thank you.
All right. In addition to that, I want to mention that nowadays another important area of machine learning is explainable AI. So because most of these algorithms based on black box models. So once you get the result, so we can't explain it. So then nowadays we have the explainable AI, then we can explain. For example, in this research, so you can explain. So if you have used the explainable AI method, you can explain which factors directly impact on the forecasting. So then in the next stage, you have to consider about that one also. Okay.
Okay, thank you.
Okay. So any other questions, please?
Yeah, I have a. I'm going to ask about the data. So when you select the data set, how you select the features or the variables from the data that you had?
Actually, I was considering mainly I was analyzing the past research studies, and I have found that most of the variables were the type of the soil, sunlight, temperature, those things. But so if we consider the types of the tea, there were there were no that much of considerations given to those variables. So that I have searched them manually from the Sri Lankan Tea Board and also from the central bank. So I have just collected manually and used as the data set.
How many features were there?
Totally, there were in 5.
Okay.
One question from my side also. Now, how far away you can forecast through this algorithm?
By using the previous data set, that means I have just used 80% of data for training the model. So by using that one, the next month can be forecasted. Only the next one, next month.
Next month. So your performance metrics were based on that.
Yeah.
One way to justify your method and evaluate the performance is to just compare your results with some other papers or existing work. Did you do that?
I have found most of them have used support vector machines and neural networks. So from that, I have found somehow it's acceptable accuracy that I have got. So in that way,
I think it's better to show it as a graph. Maybe your forecast variation from your intended results. Maybe that will be really great so that we can see how your results are deviated from the actual ones and those things. And I didn't get what's the classification problem that you showed also. Is it related to forecasting?
I didn't get your question.
The classification problem you showed, the classification thing you showed in your presentation, is it related to forecasting?
Are you asking about the types of key I am using for this?
Yeah.
Yeah, actually, I'm finding the forecast of based on the T types only. So for a particular T type for the next month, how the export quantity for that and how the export price for a particular T will be. So that only I'm trying to find from this.
You solved a classification problem there. As I I have misunderstood, but is it necessary for forecasting?
I think I have done that one, but somehow
Maybe I think it's two independent problems. You can pick T type and do the forecasting for that model. Because otherwise there will be two errors adding up. Classification thing and forecasting thing, when you combine it, it won't do the intended work, I guess. Maybe you can think of that also.
Okay, thank you.
Okay, thank you.
Okay, then. So any other questions? So okay, then shall we go to the next presentation? All right, then the next presentation will be on fuzzy logic based learning style selection, integrated smart learning management system. The paper was written by SPM Arachchi, DU Vidanagama and WMSK Ilmini. And presenter will be Senuri Patmila Mutukanda Arachchi. Is a final year undergraduate from Department of Information Technology, Faculty of Computer Science, General Surgeon John Watalawala, Defense University, Sri Lanka. Okay, Miss Senuri. So now it's your turn.
Good morning, all of you, and welcome to my presentation, Fuzzy Logic-Based Learning Style Selection, Integrated Smart Learning Management System. Author SPM Arachchi, co-authors DU Vidanagama and WMSK Ilmini. Introduction. Learning materials that contain the entities of each learning style can increase the understanding level of each individual subject. Each learning style of Felder-Silverman model can be categorized as visual basic learners, which consider about the images, graphs, audios, videos, and many other attractive objects. As well, the reading-based learners who are based on text reading. Methodologies that are used for the learning style detection contain advanced pattern recognition techniques, which are based on huge amount of data sets. Fuzzy logic can reduce this complexity. Problem identification. So the problem that I've identified was that the instructors in a specific university cannot identify the number of learners which were going under a specific learning style. So if there is such mechanism to identify the number of students in a particular learning style, that instructor will get a big advantage to create their learning materials for the better understanding. Objectives of this learning management system to enable a learning style selection feature using fuzzy logic that enables instructors to prepare their learning materials based on each individual's learning preference. And it also helps to increase the level of observations. So it will reduce the complexity of learning style selection. So rather than using complex algorithms to detect learning styles, it works similarly to human reasoning. So here are some research papers which I've considered. So the first research paper contained some features like information gathered to implement supervised training model. So mutual similarity pattern recognition used to identify the learning style of each user. Drawbacks of this system which I've identified were need a large memory to collect data, need complex algorithms to detect learning style. The next research, it contains the features like content-based filtering, collaborative filtering, hybrid filtering, were considered as recommendation techniques. So these are some kind of primitive methods. In the next research paper, it has the features like it proposed a recommend system which is based on e-learning material, which is based on ontology. Once we go into the ontology, it creates lack of versatility and difficulty to modify. And particularly, those are dealing with a lot of information as well. In the next research paper, it contains the features like to extract learning style, it accesses weblogs of each learner, pre-process weblog files, create learning style model, and build tree using decision tree classifier, predict learning style model were taken as major steps. So as the drawbacks, decision tree learners can create over-complex trees that do not generalize the data well. Decision trees can be unstable because small variations in the data might result in completely different tree being generated. So the methodology. This research paper expressed the learning style prediction based on 2 examination results. Each examination is a quiz which include 5 multiple choice objective response questions. The freshers who are going to access the learning management system for their first time can get the chance to attempt to the 2 quizzes. The first quiz contains the theorem, and it will elaborate it using the graphical content. So after the elaboration, learners should participate on a quiz to obtain marks. Second quiz contains a theorem that elaborate using textual content, and after the elaboration, learners should participate on a quiz to obtain mark. So those marks will of the 2 quizzes will be evaluated, and then it will predict the probability of being a visual learner. So these are the fuzzy inputs which I've considered. Each student contains 2 quiz results. Those quiz results are the fuzzy inputs of this fuzzy logic system, and each result set has 5 triangle membership functions. They are very low, low, average, high, and very high. Fuzzy outputs. So the fuzzy output is the being a visual learner. So there are 5 membership functions in the fuzzy output. So they are not a visual learner, unsuccessful visual learner, average visual learner, successful visual learner, and top visual learner. Here are the fuzzy rules which I've considered in the fuzzy inference engine. So for the fuzzy inference engine, going to take into consider each rules in the fuzzy rule base. So to generate the fuzzy output, this research paper considered results of 2 quizzes. So they were named as quiz 1 and quiz 2. Here is the membership function of the fuzzy input. And then this is the membership function of being a visual learner. So I've used MATLAB to generate this MATLAB script. And here are some random inputs which I've considered, and I got the performance value of each. As in the discussion, the end product of this research is to boost up the learning style selection by allowing students to participate in 2 separate quizzes the first time that student logs into the system. A group of students who knows their learning style via a psychological session will be selected out of a university, and each student will be evaluated by a test regarding their learning style as similar to the LMS. So this will generate the result that the truth of being a visual learner. So for the conclusion, rather than using complex algorithms to detect learning styles, it works similarly to human reasoning when we are using fuzzy logic, as well as any user can easily understand the structure of fuzzy logic. It does not need a large memory. Algorithms can be easily described with fewer data and easily provides effective solutions to the problems that have high complexity and uncertainty, while we easily modify the rules in fuzzy logic system. Here are some references which I've considered. And for the acknowledgement, this research was supported by Mrs. D.U. Vidanagama and Ms. WMSK Ilmini, Department of Information Technology, General Sir John Kothalavala Defense University. Further, the appreciation goes to all senior and junior lecturers for their valuable comments and continuous support. Finally, also, we would like to appreciate our colleagues for the support they offered us in the completion of this research. Thank you.
Okay, now the floor is open for questions.
Few quick comments. Thank you very much for the presentation. Now, when you talk about this teaching, learning, assessment are three pillars. Okay. Then you have done the study in assessment. Am I right? Yes. Okay.
Yes.
Learning styles comes on to the learning part. The learning component, there are now, what are the learning styles? There's a method called WARC, visual, auditory, then kinesthetic, then what
Auditory.
auditory, right? These four has to come. Now you have checked only visual part in
As
your
well as reading.
the reading,
Yeah.
right? Yeah, those two. You have not considered other two, right?
Yeah.
That is one point. The other point is, now when you are looking at this one, you have to look at this Honey and Mumford. There's a method they have described. If you have to identify the visual, what are the factors? So you have not considered that one, right? So what I feel is, like you have to look at all factors, right? All factors, and then only you will be able to check in that model whether is it fit to that learning styles. Okay. So did you do that one? Did you refer the Honey and Mumford method, the criteria?
No, sir.
Please refer, right? Okay.
Okay.
And what is your sample size?
Actually, I do not need
No.
any.
In your model, like you did a study, right? That,
Yeah, I still didn't did that study. I will continue it as the further work. As up to now, which I've done is I created the fuzzy logic system only, sir.
all right, okay, thank you.
Okay, any other questions, please?
I have one question. So if you take this, when you are considering the methods of identification of the methods, you have taken, as I said, visual learning, and you have given a questionnaire.
Yeah.
So have you, what I understood is that you do a pre-psychological session for them to understand what is their level of the method of learning as well.
Yeah.
So in that means they are having a prior knowledge about what is their learning style is.
Yeah.
Yes. So after that, you evaluate it through a questionnaire.
Yeah.
So have you considered any rather than answering a question, if you have given a kind of a and give it to the student an actual measure and see whether with that. Otherwise, sometimes having a pre-knowledge about their learning style, they might get the bias towards coming into that idea. So you'll be able to improve that if you incorporate that kind of an approach as well.
Actually, madam, I've considered that the psychological test for the students will be evaluate the truth of this system. So therefore, I've considered the psychological test. So the results of that psychological test will not be shown to the students. So therefore, I think
Okay, any other questions? Anyway, so you have done good research on your undergraduate project. No, so this is undergraduate project.
Yeah,
No?
yeah.
Okay. Okay, then if you don't have any other questions, so we can go to the next one. Okay, thank you very much, Ms. Senuri. Okay, then the next one will be on facial recognition based on the next one is on computerization of flashcards for early childhood education by AVN Sandamini, MKP Madushanka, and Premaratne. And the presenter will be Miss AVN Sandamini, and her biography is she's a software engineering undergraduate from the Kotalavalavara Defense University, who is currently completing the internship period relevant to the final year. This paper demonstrates the research conducted regard to the final year project. All right.
Good morning, everyone. So today I'll be presenting you all my research done on computerization of flashcards for early childhood education. So first, so first let me introduce what is this topic on. So this is going to be a portable and easy to use digitalized learning platform for children under the age of 8, whom we are calling children in the early childhood, which is built according to the Sri Lankan education context along with the NIE syllabus. So NIE was cooperating with me on selecting the syllabus and the categories, and the guidance and teaching methodologies built on focusing the learning and teaching process based on flashcards, which is commonly used in learning and teaching process of the children. So this is going to be simply a computerized flashcard system specialized for children in Sri Lanka under the age of 8. So what this concept is for, so basically, as y'all can see in the image, with all these pandemic situations and all the economic crises happened in Sri Lanka, most of the time we saw that for school education, there are online platforms. For university education, there are online platforms, but there was a gap for early childhood education. So that is why such an application is needed in Sri Lanka for early childhood education. So simply, if I put it into points, the problem that I see is the lack of a learning platform for early childhood education in Sri Lanka, enhancing primary education among the children in more innovative manner using technology, making use of technology to educate children in their early childhood, and teaching the children the native languages used inside the country. So the native languages part, it is implemented inside the application, so it will be going on. So in the next slide, y'all can see it. So what is the solution I came up with? So basically, I'm going to introduce the first object detection application introduced to read and display the name of the detected object in all 3 native languages used inside Sri Lanka, which are English, Sinhala, and Tamil. Which the application is going to be specialized for children in their early childhood. And what is the aim? So the main aim of this proposed system is to develop an application which will help to fulfill the fundamental foundation of education of Sri Lankan children under the age of 8 with all 3 native languages, Sinhala, Tamil, and English. So the language will be given as textual as well as voice outputs. And what are the objectives? So to introduce an online platform for learning process of early childhood, which is lacking in the current Sri Lankan education system, teaching young children all 3 native languages used in means of communication inside the country, to prioritize early childhood education in online learning methodologies, and to develop a simple application which is easy to be used by children and assisted by preschool teachers or even the parents. So simply, this is the proposed methodology to be used. So this is a mobile application. The user can click an image, and also they will be given the opportunity to select the category, and the image click will be recognized using the model developed, and the user will be getting the detected image with the detected name, the object name, in all three languages, Sinhala, English, and Tamil, as well as the voice output in all three languages. So this is the whole development methodology. So data is collected, they are processed, and they are trained, validated, and tested in the range of 60 to 2020. And then the trade model is developed and evaluated, and they are tested to get more accuracy and efficiency. And in the meantime, in the user side, I have used PyCharm as an IDE to develop it in Python, and TensorFlow, Keras, OpenCV, Google Trans, and GTTS are used in the development to all these translators as well as for the voice outputs. And Kiwi is used as my development language for the UIs. And so you all can see the image is captured and it is going to the pre-processing process, and then it is predicted by the model, and it is mapped with the word using translators. And after the translators are translated, so it will be given as our voice output using Google translators as well as using GTTS. So that is the whole development process which is inside this application that I'm going to introduce. So this is a mind map of the application. So basically, the user is given a chance to select a category. So going on with the NIE syllabus, I've selected some categories. So I'm still in the development stage. So when I'm implementing and going on, I thought of putting more categories on. And as you all can see in the third interface, you all can click image, and on the fourth interface, you all can see the image is detected with the name, and it is given in Sinhala, English, and Tamil with the voice outputs related to the language they are going on with. So basically, for the user interfaces as well, I did the research part where you have to use specific colors, and because this application is going to be for children, so you have to use specific colors and all. So I've considered all in the development process as well. So this is a dataset training part. Currently in the development stage, I have selected 4 categories. 4 categories: animals, plants, animals, fruits, vegetables, numbers, and letters. So this is a dataset accuracy and accuracy rates I've used. So I've trained around 22,000 to 225,066 images with 80 classes for this data set, going along with for data sets for fruits around 67,692, and for vegetables training about 150,000 images. So these are the categories I've trained for now. These will be increased with the development of the application. So they were giving good accuracies as well. So this is the current interfaces I've developed for the application. As you all said, I've been considering the colors and as well as the colors that should be implemented in the applications which are used for children. So basically, you all should be always focusing only on the things that should be focused, other than adding all the features and all. So that's why the interfaces are very simply made. So as you all can see, the welcome page, also you all get a voice output for your name. When you click on the grid, you'll get the greeting saying your name, and the user is given the selection opportunity, then the click of the image, and then the detection part in all 3 languages going with the voice outputs. So as for a conclusion, this is a simple and easy to use application which will help to enhance the knowledge level of children under the age of 8. As I said, the children in the early childhood. This will also help to improve the Sri Lankan primary education system as a new platform for early childhood education as for the process of online education in all 3 languages, Sinhala, Tamil, and English in use, because as I described, there is no application for the children under the age of 8 in Sri Lanka currently. So if we can implement something like this, that will be a great opportunity for the children under the age of 8 to enhance their education through technology. So this will be fulfilling the gap of online learning and teaching methodology of primary education of Sri Lanka. And also the special scenario is, so this is fully built upon the syllabus and the help of the specified methodologies used in NIE. So if we can implement it, it will fill in the gap, which is for early childhood education in the country now. So these are the references I went through in doing my research and developing my application. So I take this opportunity to thank the supervisors, the coordinators for their massive support and guidance given throughout this process, and a special gratitude for the help given for the research by the NIE of Sri Lanka. And finally, I would like to thank all the staff who taught me and supported me on achieving the objectives. So hopefully I'm hoping to finalize this and give this product out. That's all. Thank you.
Okay. Thank you, Ms. Sandamini. So that is computerization of flashcards for early childhood childhood education. Any questions, please? Can you switch on?
Yes, sir. I'm a little bit confused why you are using a training model for that, because are you going to capture something and ask for the baby?
Yeah, so as I shown here, so basically the user is going to capture an image. So after that, they can select a category they want. So it can be, so this is going to be assisted by a preschool teacher, the parents, or someone elderly. So after capturing, you can select, is it a fruit, a vegetable, and numbers or letters. So after that, the captured image, according to the category they have selected, only they go through the model and select what is the captured.
That's why you're trying to-
Yeah, that's right.
I didn't get that capturing.
Yeah, okay.
That's why.
Okay, that's right.
So then how do you, so for example, then you capture the image.
Yeah.
So then, so there may be several objects in the image, isn't it? So then how do you identify those objects?
So basically they're going to capture the image, and after that they're going to select the category. What is the image they're going to capture as
So
it is.
those things identify automatically, or so you have to?
So I'm training a model for the categories as to the vegetables, fruits, and numbers. So when the image is captured and this category is selected, as this is assisted by a preschool teacher or a parent, so using the model trained, the object will be detected with the category they have selected.
So then only one object will be captured at once.
Yes.
Okay.
I have one.
Since we are dealing with
I have one question. So when you are training the model, so the data sets that you have already taken, which is when you take the fruits and all, the whatever the data you have taken, not maybe particularly for the Sri Lankan context, like many fruits, right?
Yeah.
So have you test with Sri Lankan, whatever the specific foods like Veralu or something like that, and whether you train those type of, because now modern the tools and techniques for children, so better to have sort of a very unique things specifically for Sri Lankan context. It will be the because it's like you select the group of people like age of 8.
Yeah, under the age of 8.
Yes. So when you are, did you test this system with the students, the children?
Not yet. It's in the development stage, and as you said, as there are so many categories going on, and yeah, I didn't specialize it for Sri Lankan fruits. Are like, yeah,
it should be like that.
Yeah,
like
okay.
we have some special specific things which is related to the Sri Lanka. It would be very good and ideal to select and capture the data and train the model when you are collecting the data for training the model.
Yeah, sure, I'll add it
Just
as
a
an
suggestion.
improvement. Yeah.
Can I ask a question from Zoom? Yep.
Yes.
Now, since we are dealing with children, now when you after capturing this accuracy of the output should be 100% because it can't be wrong. How can you achieve this goal?
So this is still in the development stage, and I'm hoping to test it with like children in different age groups. I'm going to select some children and I'm going to do a parallel test where one children is given the flashcards and the other children using this mobile application, and to see what is the improvement they are going to get. So that is the testing strategy I'm hoping to use. But currently this is still on the development stage. So yeah, so to get that accuracy, I'm hoping to do a testing strategy as I said before.
So
Yeah.
at the moment, how many pages do you use?
So for different categories,
Yes.
there are around for animals, actually I tested around 22,566 images with 80 classes. And for the other 67,692 images with 131 classes, and 15,000 images with 15 classes for vegetable dataset.
So that means so per class you have only very less amount of number of images, no? So you are going to use deep learning methods, or so have you used deep learning methods?
Yeah, for training and also.
One quick question. Do this NI is having the preschool curriculum?
They don't have a specific NI curriculum, but as I discussed, they gave me the curriculum for the children, which is used for grade 1 and 2. So I go through it, and with the discussions only, I came up with the categories.
So this is not for the preschool grade 1, am I right?
I wanted the development for the people who are under the age of 8, as they don't have, they were okay going with the syllabus for grade 1 and 2 because that is the syllabus they use for the children under the age of 8. Yes.
Can I ask again another question?
Yeah, sure.
Yeah. Now, do you think that machine learning is necessary for this application? Without machine learning, can we develop this app? I believe so. That's right.
So basically, I went on with that because there are so many categories, and as for the object detection part, only I went for that. Maybe I can try it as well for in the future development part. Yeah, I can try
because
it
now the only concern, you can improve the app definitely, but I believe with this much of classes, achieving this goal with limited power and with high accuracy, at least almost 100%, is really difficult. Either you need to reduce the number of classes and bring up this accuracy level to 100%, because it should be 100% because we are dealing with children and we are going to teach them something. So it should be 100%. Otherwise, we can't achieve the goal that you have set up. Maybe for different application, this may be suitable, but for this particular application where you're dealing with under 8 years old children, I think the best, this may not be the best application, but your setup definitely can be used for some other thing, I guess. For children, I guess, without machine learning, this application can be implemented simply. You can emulate what we do with flashcard, normal cards, the physical cards. You can emulate it with an app, maybe. That's my suggestion, but don't worry, this is good news. The training process and everything you can use maybe for a different application. Since you have now knowledge and everything, you can just plug and place it to a different application, I guess. Maybe it's my view. Okay, thank you.
Okay, thank you very much.
One quick question. Do you go beyond object recognition?
Yes.
That means if you want to teach some addition and other things, you use these flashcards for that as well?
Sorry, I didn't get
no, if you want to, according to the curricula,
Yeah.
if you want to add 2 objects and see the outcome, so do you use this as well? Do you go to that extent?
This is currently only for one object to be detected.
Currently only for one object.
Yeah.
And since you are, this is just a suggestion.
Yeah.
Since you are dealing with small children, if you can have a limitation to stop the children using it continuously, that aspect.
Yeah. So in the discussion, in the discussion I had with NIE, I asked the same question. Do we have a limitation for screen timing? So what they came up was they don't have a limitation for screen timing currently. So yeah.
Even though it is not there, better.
Yeah. So yeah, we can add a timer maybe. So yeah, for the application.
Okay, shall we go to the next one? So if you don't have any other questions. Okay, thank you very much, Miss Sandamini. Okay, then the last presentation will be facial recognition based temporary employee management system by KAJV Arunarathna, JJRS Fernando, and DMR Kulasekara. The presenter will be Mr. Arunarathna. So his biography is Mr. Arunarathna is an officer cadet from Intake 35 who is following a BSc Honors Software Engineering degree program at the Department of Computer Science of General Laveena Defense University. He has successfully completed his internship at the IT department of the BAM Knitting Private Limited. He is interested in research areas such as image processing, cybersecurity, and digital forensic. Okay, Mr. Arunarathna, now you can continue.
Good morning, all of you. I'm going to present research on face recognition-based temporary employee management system. Firstly, I move to the introduction. Why temporary employees are needed? There are 2 employees in the companies. They are permanent employees and temporary employees. And also the companies has 2 specific tasks. They are permanent tasks and extra tasks. Extra tasks means unnecessary changes occurs in the company. It is extra tasks. In permanent employees cannot involve these extra tasks because they have relevant assigned specific tasks. According to that, the companies hire temporary employees. It is very advantageous because they need to give day-to-day salary only. And also companies need to hire the permanent employees. They can hire the permanent employees through the temporary employees. And next, move to the aims of research. Analyze and introduce a software application in employment sector developed for the benefits of temporary employees and other related stakeholders in worldwide, and analyze the solution of face recognition based temporary employee management system. The screen shows the sequence of my research presentation. background. In Sri Lanka, 90% of temporary workers are working in the private sector, and overall around 60% of employees work as temporary workers out of 2.8 million private sector employees in Sri Lanka. An increase of temporary employees in private sectors and the permanent employees into nearly 1:22 ratio. And the figure shows the temporary workers as percentage of wage employees in selected Asian countries as well as in Sri Lanka. The main part of research presentation is the research problem. It is mainly one between the companies and the temporary workers. The first research problem is that they do not have a valid ID for the temporary employees like permanent employees. According to that problem, they have wait until the outside in the company their identity is confirmed. It is very disadvantageous to the companies because their effective is reduced and the time will wastage. And second part is the payments are made using the written notes, and many of these written notes are misplacement, and the companies can't give their correct fully payment for the temporary employees, and temporary employees can't get their fully payments. And the other problem is the brokers. Brokers get their companies hire the temporary employees through the brokers, and brokers companies give their salaries to the brokers, and brokers keep some money of temporary employee salary and other salaries are distributed. And other thing is difficulties of dividing tasks for employees, and the companies don't know their temporary employees capabilities, who are capable of the task, and the temporary employees can't give their maximum support to the companies because they can't achieve their task successfully within time. And other thing is waste of working time due to the lack of proper schedule for temporary employees. These are the functional requirements registered as temporary employees, giving review for employees and giving the task to the best temporary employees. The system recognizes the temporary employees and the assigned tasks according to the reviews. The arrival time and date will be recorded. This system will ensure salaries are adjusted, corrected in the payroll management system, and all data is recorded in the database. This is the research gap between the current system and the proposed system. In current system, they are mainly in stakeholders are company, temporary workers, and brokers, and platforms are manually and registered and identify temporary employees in manually, and payroll management system in manually, can't select people for suitable works, no security, and less reliable accuracy efficiency, and mostly salary distribution done by brokers. And proposed system, they have two stakeholders, company and temporary workers, and platform is desktop based with web-based system, and the register and identify temporary employees in automated, and payroll management system also automated, and can selecting purpose for suitable works by using their rating level and high accuracy and high reliable and accuracy in efficiency, and salary distribution only the company. This is the methodology. They have two main application, standalone desktop application and temporary employee management payroll web application. And standalone desktop application mainly focus on two sections, sectional head section and admin section. Admin section done all the admin parts, and sectional head manage the temporary employees by giving rating, assigning tasks. Likewise, this demonstration shows the is to understand the system. There are mainly three sections: admin section, sectional heads, and temporary employees. Admin section done the registration of the temporary employees, and they are edit their registration some details, and mainly the newly registered employees come to the company and giving their details and fill their tasks and the other things in their preference, and giving get their images in I use LBPH algorithm that use 200 images for best accuracy and use gray color images. And after the training these images, and it is used LBPH and cascade algorithm for detecting features of the face. And the next day, the washing section wants to get additional work in their section. The section head assigned task for best rating, highest rating person and giving task for them. In this, the newly registered person give task, and after the giving their task to this section, any other section can't get this employee because it is only the washing section for next 24 hours. And next they come to their companies, and the in front of the camera he face detection. And after the face detection, their task, their section, and their ID numbers are detected. And after their attendance will be automated, and according to the attendance, payroll management system also automated. And next task is the sectional head. This is the company should get their workers in best temporary employees. According to that, the rating level give standard methods, and after the calculation give new rating level for these employees according to their performance. And finally, this desktop application with web-based system. The web-based system mainly focused on temporary employee management system. It is temporary employees can register using this web-based system for the company, and also they can see their payroll system and the tasks and the section. And the main thing is they can get their salaries in day by day. The permanent employees can only get their salaries on the per month. In this, especially for the temporary employees, can their salaries in day by day. The solutions. The research problems. The first one is do not have a valid ID, so they have to wait until their identity is confirmed. In according to the demonstration, the identify is confirmed by using the face recognition. Payment are made using these written notes. It's no any written notes in the current system. The payments are given by payroll management system, and problems having due to the presence broker and between the company and the temporary employees. There are no any brokers between the company and temporary employees. Difficulties of dividing tasks for the temporary employees. Now the problem, the proposed system, the companies know their capabilities for their giving tasks, and the sectional head give rating for temporary employees and according to their work, and waste of working time due to the lack of proper schedule for temporary employees, and display tasks and section using face recognition. And last one is can't identify the good temporary employees, assigning tasks for best temporary employees according to their rating level and giving grading for overall performance. And they use LBPH calculation and use gray color images and calculate their identification. And the rating calculation, there are 3 grading levels: poor, good, and very good. And I use standard method for calculate this rating level. And these are the testing and result. They validate the face identification of various facial appearance. I use face recognition with beard and without beard and with mask. And next one is validate the face identification of various light condition in daytime and night time. And next one is validate the face identification of different people. Think the 2 persons come to the companies in and one time, the system can identification correctly the 2 persons in one time. This is the validate the face identification of digital images. The digital images, this system identify digital images. The temporary employees can cheat easily. In this case, the digital images not identification. Another one is validate the face identification of various face angles in and next one is testing statistic of face module in the screen shows their calculations. the limitation. This system can't use for permanent employees because only the temporary employees, and review is done by manually. It can't be done in automatically. And in face identification not working in different seasons, the example faces of employees cannot be recognized, the came covering the face. These are the references I went through. And acknowledgement. I would like to thank for my supervisors, Ms. JJRS Fernando and DMR Kulasekara. And I especially thanks for Ms. Ilmini Madam and Upesa Miss and Captain Imran sir to giving support to the participate this event. And thanks for.
That is a facial recognition based temporary employee management system by Mr. Arunarathna. So now it's open for questions.
I have a one question. So why you have selected only for temporary employees? What is the barriers to having it for permanent employees?
Because in my personal experience, I in work in the temporary employees 1.5 years, and the permanent employees have many systems for their companies, but temporary employees don't have any system for their companies to their help. According to that, I face these problems in my lifetime. According to that, you create this system.
Yeah, that's good. You are selecting the temporary employees, but if you implement these type of things, it's better that if you can integrate that permanent employees,
yes,
that,
can
then
be,
one system can be good
yes.
for a whole permanent employees and the temporary employees as well. And also, I have a small question, like so when you are recognize the face, if somebody is getting accident or damage or having some sort of a problem in some area in the face, how could the system could recognize?
In the limitation, I use the covering face.
Okay. And also when you're collecting the data, it says different sites you are collecting the data. It's when you are collecting the data for the data set, you are a different angle, you are collect the data, right? Okay.
So why did you use face instead of face? So why can't we use the fingerprints to detect the temporary workers?
Because temporary employees having less knowledge, it is easiness of the temporary employees. I use face recognition because they want to stand in the camera.
So how about the permanent workers? So how they get the presence or the absence in for the permanent workers in the company? So you implemented this one in a company, no?
Yeah.
So how about they get the absence of the presence in for the permanent workers? Yeah.
Not relevant to permanent system, only the temporary.
Okay. So I mean the current system for the permanent workers.
Current system only the temporary.
No. I mean for the current system. So they have a system to manage the permanent workers. No?
It is mainly used in the fingerprint method in the companies.
Okay. Any other questions, please? So any questions from students? So I can see some students in the audience. So you can ask the questions also.
I mentioned testing statistic of face module. I use LBPH algorithm. It is in the formula, the confidence level are in source in the screen, madam. The first I know various spaces, more than 80% of the formula confidence level, and face identification of various light condition more than 80%, phase identification of various phase angle more than 75%. In phase identification of different people, more than 80%. The phase identification of digital images more than 85%, according to the formula of LB linear binary pattern histogram algorithm. Small time the system can identify the demonstration like demonstration.
So how about so if a colleague just present an image of his friend, so how does the system detect that one? I mean, in case, so for example, a worker's image is present to the system.
Not identification. The digital images taken from camera, there's not identification in the page, in the display. So not the display unknown.
Yeah, one more question. So if twins are working in the same company, will it be able to identify those people?
It is a problem. Use KAJV algorithm for features for identification of edge features like.
Any other questions, please? Okay, then shall we wind up the session? So this is the last presentation. So I would like to thank all of these people who presented the research papers. And I would like to congratulate them for their research work, and I hope that they will continue the research and be productive and do a better job for the country. Okay, thank you very much.
Thank you, sir. Ladies and gentlemen, we have now come to the end of the Computing Technical Session 2. I would like to invite the chair of the session, Professor TGI Fernando, to present the certificates to the presenters. You may come forward as I read out the names. SPM Arachchi, AVN Sandamini, KAJV Arunarathna, in short notice, I would also like to thank our Laveena for her presentation, even though she is unable to receive her certificate physically today. So please remain on stage. Now I would like to invite Dean Faculty of Computing, Dr. ADAI Kudagamage, to present the token of appreciation to the chairperson. Thank you, sir. We have now reached the end of this session. On behalf of the organizing committee, I would like to extend our heartfelt gratitude to Professor TGI Fernando for chairing the Computing Technical Parallel Session 2. With this, we conclude this session and I invite you all for lunch just outside. Ladies and gentlemen, please be present here by 1 p.m. for the technical parallel session 3 on the theme Natural Language Processing and Applications. Meanwhile, I have a small announcement to the presenters and the chairpersonals to remain for a quick photograph. Once again, thank you very much and have a pleasant afternoon.